Hi friends, welcome to follow up. In this video, we are going to practice several problems related to binary tree traversal. We are going to start from this problem, 651, binary tree vertical order traversal. These are some problems in lintcode, right? It's a similar one as lintcode. So we start from this problem. The reason is that some people told me that this problem is a Facebook common interview question, right? So let's first look at the description. So here, given a binary tree, we want to return the vertical order traversal of its node values. In other words, from top to bottom, column by column, right? So here, there's a node for each node at position row column. In other words, you think of a coordination, right? Its left and right child will be at positions row +1, and this left will be column -1, and the right will be column +1. So the root of the tree is at 0, 0 position, right? So here are two examples. In the first example, you see we have none, right? None is 1, and 3, 15 is 1, and 20 is one column, and 7 is another column. So this is also, the return is a list of lists. So in the second example, we see that 1 is none, and 1 is 4, another is none, and in the middle we have 3, 0, 1. So here we should have 3, 0, 1 rather than 3, 1, 0. So 0 and 1 in the same row and column position, but 0 is in the left, right? So also we have 8 and 7. So for this problem, we're going to solving it using breadth-first search traversal. Breadth-first based traversal. Let's see. Basically, some people write BFS, breadth-first search, but let's write BFT here. So basically, we regard that we just need to retrieve the column positions or indices. So then, because the level automatically give us the row. So meanwhile, we need to know what's the leftmost row. So in this one, we are going to use this column indices as a dictionary key, right? So here, this is the relevant data structure, dict in Python. So with that said, let's look at the coding. So actually, if you have practiced quite a lot on this kind of problem, so this should be rather verbose, right? So here, because it does not have some constraints specified, we need to check this special cases. For example, if not root, so this is an edge case, we are going to return an empty list. Let's mark this as edge case, right? Treatment. So typically, if you work on problems related to binary tree, so if you write some recursion solutions, so this can also be a stop condition or base case. So once this is done, so let's prepare a result. This is going to hold the list we are going to return. And then let's initialize a queue. So here we can use a list, and then we pop left. We use the left as the queue head, and the right as the queue tail. But here, in order to accelerate a little bit, so I'm going to use collections deck. So we just need to use the queue behavior. So here, the thing we want to put is a root node. This is the tree node, right? Then we are going to do the traversal. So this is the very standard well queue. So first, so here actually we forgot some information. So we need to retrieve the column information. So here we have node. This is a tree node, and this is the column index, right? So this is integer. So we regard the tree node is at the column index 0. Then to the left, it's going to decrement, and to the right, we're going to increment, right? So once we have this, and then we get the node and the column. If we do Q pop left, right? So then each time, so because we also want to retrieve this in a dictionary, so let's do collections. Let's see if I type correctly. Collections default dict. So here I'm going to put a list as a container. So here you can use result, you can all use some auxiliary, right? So then what I'm going to do is auxiliary. So I'm going to use the column index as the key. Then I'm going to append, right? I'm going to append this node value. So this is standard, right? Then we are going to check the neighbors. So due to the requirement, we need to have from left to right. Let's first do left child. If node left, then what we are going to do is to queue append. So we are going to requeue this one, node left, and then the corresponding column index will be decremented by 1. And if node right, then we're going to do the same thing, but this is right, and then we increment the column by 1. So this way, once we finish that, we can prepare the return. So this part is the main breadth first based traversal, right? And then we prepare the return. So for this return, so we need to know, so we should return the list corresponding to smaller keys first, right? So basically we can do a sort. So keys, let's see, sorted aux keys, right? And then we prepare the return like this. So we are going to return aux key for key in keys, right? So because this sort will make this keys or the column indices from small to large, right? So this is what we want to return. So up to now, we finished the coding part. So we can do a test first. Let's run test. Yeah, it passes, I guess, the first example. So now let's look at the generic case. Yeah, it passes all the cases. So here we just give one solution format. And actually, this problem you can write in different formats and different ways. So this is just a demonstration. I guess that's about it for this current problem. So next, I'm going to do another problem, which is a very relevant one. That is problem C69. So for this problem, this is a binary tree level order traversal, right? So let me first full screen, and let me read the problem statement and then do the coding with very short explanation. So here we are given a binary tree. We want to return the level order traversal of its nodes values. In other words, from left to right and level by level. So this is very easy to interpret, right? Like this one, we should have returned this one for this level. And for the second level, we are going to return a list corresponding to 3. So similarly, you can see here, we have a list contains 3 single element list corresponding to different levels, right? So here are some challenge. So actually we can do this very easily, but here for pedagogical purpose, let's just give one solution format. If you want to see more such problems related to binary tree traversal, you can check out my YouTube channel for the playlist, for the corresponding search for the binary tree playlist. So for this one, I'm going to use a very, very verbose way, but it's still very efficient, right? So first, let me edge case treatment. So if not root, I'm going to return an empty list, right? This is reasonable. And then we do a level order traversal. So this is very standard. So first I'm going to initialize a result variable to hold those lists corresponding to different levels. And then I initialize a level list. At the beginning, it contains just the root itself. because we have already treated the edge case, so this is not null, right? So we have a level. Now let's do the while loop. While level. If this level is not an empty list, then we are going to add the corresponding values for the current level to the result. Then result append. Then we append a list to it. The list will be node value for node in level. This is standard list comprehension, right? And next, after we've scanned this level, we're going to update the level variable. So this is another list comprehension. So we can do child for node in level, for child in say node left, node right. So here the order is important. If child, we're only focusing on child that is not null. So once you finish this while loop, the result will be prepared. Will be prepared. So we are going to return the state of the current result. So this actually, this pattern of code actually can be used frequently for addressing a large number of problems in LeetCode or in lintcode here, right? Let's first do a test. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the cases. I guess this is the second problem for this video. So now let's look at another problem, actually similar problems related to this problem. So let me change to the third problem. So this is the third one, right? So for this one, let's see. Let's still make it full screen. So this is a binary tree right side view. So now that you have the right side view, you can also think of the left side view. Actually, the idea will be the same. So our goal is to use solve this problem. Solve this problem by level order traversal. This is actually a very natural one, but you can think of some optimizations. But that's not essential for the main idea. So here again, given a binary tree, we want to imagine that we stand on the right side of it, and we want to return the values of the nodes we can see from top to bottom. So for this one, you can see 1, 3, 4. You can think there are some light pointing to the left from the right. Then you can just hit 1, 3, 4 here. And for this one, you can see you can have 1, 3. But notice that in example 1, if the subtree rooted and 3 have no children, then you should return 1, 3, 5, right? In other words, for each level, we need to return the rightmost node or node value. That's actually the simple observation. So with that said, let's directly look at the coding. So basically, the idea will be the following. So we do level order traversal, and then in each level, we just retrieve the last value. So first, I'm going to treat edge case or edge cases. So if not root, I'm going to return an empty list. And then we do level order traversal. This is actually super straightforward. First, we initialize a result variable, right? So this are going to hold the node values for those nodes we can see from right. And then we initialize a level. So this currently just have a root, as we mentioned in the previous problem. So because we have already treated this edge cases, so root will be not null. In other words, this level is indeed a non-empty list. And then we do standard while loop, while level. So for this problem, it's different from the standard level order traversal. We just need to append the level, the last element that is -1. And this is a tree node, so we can access its value attribute or field. So this way, we finished adding the rightmost, and then we are going to update level, right? So this is actually another list comprehension as in previous problem. So we see child for node in level, for child in node left, node right, if child. So here we focus on those child that are not null. So once you finish this while loop, so this result state is prepared, so we can make it returned. So we return the result. So this actually forms a very simple solution format to this problem. We can do a test. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the cases. So here a quick comment is that this one is essentially level order traversal. And then if you want to see this tree from left to right, you just need to return. So here change -1 to be 0, right? You return the first one from each level. So this is about this problem. Another small comment is that the two examples are not very representative. For example, if you can add one example which do not include the 4 here, then you need to return 1, 3, 5. This is more suggestive. That's basically about the third problem here. So now with this problem done, let's look at another one. So this is the level. This is this is a level order traversal 2, right? This is actually still level order traversal. Let's give a quick solution to this one, because otherwise the video will be too long, right? So here we have a binary tree, and then we want to return the bottom up level order traversal of its node's value. In other words, from left to right, but level by level from leaf to root. So this, for example, this one, you should have 2, 3 first, and then you have 1. And for this one, you should have 15, 7 first, then 9, 20. So this is actually just some order, right? We need to treat. Let's see. First, we treat edge case or edge cases, right? So if not root, I'm going to return an empty list, and then level order traversal. But I make some modifications, right? First, we initialize a result variable to hold the lists, and then we have a level. So the level currently contains root itself. As we mentioned here, this level is indeed a not empty list. In other words, it contains non-null elements. Then we do while loop, while level. Then what we are going to do is that we put the nearest added one at the very beginning. So we can do something like this. Result equals. So here I want to add a single list, a single element list, but this single element is a list. So this is let me use list comprehension here. So node value for node in level, right? Then we add the result. This way we update the result state. And then as in the standard level order traversal, we update the level. So this will be child for node in level, for child in node left, node right, and then we focus on child that is not null. So once you finish this while loop, the result is prepared. Then you can return this result. So this is this problem. So basically, you can do a test. Yeah, it passes one example. So now if you check the generic case, then you will get all the cases passed. So with that said, I guess that's basically about it for those 4 problems, right? So basically, you want to do traversals. Actually, there are other traversals related to binary tree, like pre-order traversal, in-order traversal, and post-order traversal, zigzag traversal, and more, right? You can tune and tweak in between the process, but the overall idea will be the same. I hope that you can have some feeling after watching this video. And if you are interested in understanding more about the traversals, you can check out my YouTube channel, especially the binary tree playlist. With that said, I guess, thank you for watching.